Hello, friends. This is the AlphaList podcast. I am your host, Toby. The goal of the AlphaList podcast is to empower CTOs with the info and insight they need to make the best decisions for their company. We do this by hosting top thought leaders and picking their brains for insights into technical leadership and tech trends. If you believe in the power of accumulated knowledge to accelerate growth, make sure to subscribe to this podcast. Plus, if you're an experienced CTO, you will love the discussion happening in our Slack space where over 600 CTOs are sharing insights, or visit one of our events. Just go to alphalist.com to apply. Welcome to the AlphaList podcast. I am your host, Toby, and today I have a special guest. Like almost every CTO I know owns a few of his devices, and still most likely no one ever heard of him personally. His name is Eben, and he's one of the founders of the Raspberry Pi Foundation and one of the, let's say, crazy geeks behind the Raspberry Pi, the device we all know. And I personally own one. It drives my wife mad, to be honest. Like, best wishes from her.
Yeah, I'm very sorry. I'm very sorry, not sorry.
And I mean, it's like the biggest hardware thing, independent hardware device that was there for ages, right? I mean,
it's weird. It's the third most popular general purpose computing platform in history, after the PC and the Mac, right? Because really the PC and the Mac have been so dominant that the third place in that, we sold about 45 million Raspberry Pis over the course of a decade, and third place in that championship, the bronze medal slot in that championship is very reachable.
How many Raspberry Pis?
45 million.
45 million? Times $18, so you must be rich then.
Well, that's the interesting thing about Raspberry Pi, right? It's a charitable foundation. So we're not just the third biggest computer company ever. We are the third most popular architecture ever. We're also probably the first time that a not-for-profit has ever produced computers at serious scale.
Okay,
and that translates into a marked absence of richness. It translates into a marked absence of Ferraris in the car park, I guess.
But I guess you're still not. You don't look poor, so I hope it
I
also
don't know.
worked out financially.
I mean, there's a T-shirt, you know. I haven't obviously been able to afford a razor this morning, so you never know. You can never tell. One of the wonderful things, and we were based in Cambridge in the UK, and one of the wonderful things about Cambridge is, you know, you see someone walking down the street, and it's extremely hard to tell who someone is. That you might try and make some judgment based on what someone looks like, but in Cambridge, that could be a professor of comparative philology or something. You know, it could be anyone, and it's very risky trying to make judgments in Cambridge on the basis of what people look like.
Okay, so maybe we jump in a little earlier. I mean, I typically ask my guests what their nerd path is. Like, how did they get into what they are doing? And I think for you, it's kind of special, as like it's really something special to do, right? I built this device. It's crazy popular. I built this device. How did you get there?
Well, so I guess the interesting thing for me is really the most recent bit of my career has been spent recreating for other people the way that I got involved in computing. So I had a BBC microcomputer when I was a child. This is one of those 1980s computers that sold a few million units. You turn it on, it goes beep, it boots into BASIC. You get tricked into becoming a computer programmer because you have a very programmable piece of hardware in your environment. And that was really my route in. So I was a hobbyist a long time before I have a PhD, a computer science PhD from Cambridge. But my route into it was primarily a hobbyist route, a craftsperson route, rather than an academic, a mathematical route. And really that's what Raspberry Pi has been trying to do, right? So I got in that way, observed that we'd pulled the ladder up after us, that we'd taken all of those wonderful programmable computers and we'd taken them away from kids and we'd given them games consoles and mobile phones and other things which are enormously powerful computers, but you can't program them. And then Raspberry Pi really is about trying to push that ladder back down, trying to lower the ladder back down to people by providing them with an affordable, young people in particular, with an affordable piece of computing hardware that they can use to follow that same. Because I've had an incredibly blessed career on the back of having got involved in computing by accident. And it's really about trying to give another generation of young people that kind of experience.
So your life started with 10 print hello, 20 go to 10.
Yeah, or ruder things than that. You'd sort of go into a computer shop and make the computers print not the nicest stuff in the world, it's some really uncomplimentary things, and then hit enter on each of the machines and then run out of the door and then stand up against the window watching the staff run around turning the computers off to get whatever it was you printed on the screen to go away. But yeah, that and the interesting thing is how many young people had at least that level of, because that's an enjoyable thing to do, right? So how many people had that level of exposure to computing, and how often, if you give someone that exposure, if you give almost everybody that level of exposure to computing, how often that will blossom into kind of a deeper interest in the subject.
So that is then also the vision behind Raspberry Pi, that you want to teach kids how to use computers?
Yes, and that's where it comes from, right? I mean, Raspberry Pi was a very parochial concept. We had this idea that if you could get 1,000 computers into the hands of the right 1,000 children, then you might get another 100 kids applying to study computer science at Cambridge. It was that simple. And of course, the educational aspect has grown beyond our wildest dreams. The foundation is now, it employs between 100 and 200 people. It runs vast networks of after-school clubs. It coordinates a lot of the teacher training activity in the UK. It produces lots of free online material for teachers and for learners and teachers. And then obviously the commercial aspect has grown enormously as well. So of the 45 million Raspberry Pis we've sold, probably, half, 2/3 of them are in industrial applications, have been taken into what you would consider to be OEM, industrial commercial applications. So both aspects, both the educational aspect and the commercial aspect of Raspberry Pi, have kind of become vastly larger than what we'd imagined a decade ago.
So you build it for kids in the first place, and then you suddenly realize, okay, this is for everyone, and at least industrial applications. Obviously, I mean, it's in a way it's obvious, right? But you didn't plan to do that.
No, well, we both have children. We know how tough an environment a child's bedroom is. We always say, what's the tougher environment, an oil rig or a child's bedroom? The same decisions you make to make great products for young people are the decisions that make the product fantastic for industrial environments. We don't cut corners on the product. These are cost-effective devices, but they are not cheap devices. They are not cheaply made devices, and they never have been all the way back to 2012. It turns out, we're big believers in general-purpose computing. Raspberry Pi was set up to address the disappearance of general-purpose computing from one domain, the educational domain, but it turns out that providing people with cost-effective, reliable general-purpose computers it's a growth industry. Right? It unlocks enormous amounts of creativity and potential and talent in a whole range of commercial fields, just as it does in education.
And commercially, wouldn't it be smart to also have a business line around industrial applications then, and charge much more than you do for personal computers?
Well, of course, we do provide versions of our platform which are tuned to what we would call deep embedded industrial applications. So we take the brains in any generation, of almost every generation of Raspberry Pi computer. We've taken the brains, the sort of the core processing capability, processing memory, some of the interfacing in the platform, and we provide those in what we call a compute module, which is a very stripped down platform, which is much easier to integrate into a third-party product. So we do have these products which are targeted at more purely at industrial users. We don't tend to try to charge more money, though, for them. I mean, we're very excited about we're very excited to be part of a movement, I guess, which is putting general purpose computing into lots and lots and lots of places in the world, kind of embedding intelligence into the world. And I think it would be a shame if we tried to somehow segment the business and have different margin expectations in education and in the commercial domain. So what we've ended up with is, although we do make commercial products, when you look at our single board computer product, which is nominally the educational product, actually 60-70% of those go into industrial applications. But even the platforms which are purely targeted at industrial and commercial end up, when you look at their business model, they end up having very much the same kind of margin structure as the single board computers.
Okay. And you also don't have, I don't know, special purpose software to manage a fleet of Raspberry Pis, stuff like that?
We love making hardware. We do, obviously, like all hardware companies, we're also a software company. So more than half of our engineers are software engineers, and that's just a result of how complex modern computer hardware is to operate from a software perspective. You need a lot of lines of code to make a modern chip do all the stuff it can do. So we have a lot of software engineers. What we haven't ever done really is to see software as a profit center, as a generator of revenue and a generator of profit. For us, software at the moment, and that might change one day, but at the moment, software is a cost center for us. Now, of course, there's the exciting thing about Raspberry Pi. There's a huge community of third-party ISVs, VARs, who've grown up around Raspberry Pi, who are either selling software for Raspberry Pi or embedding Raspberry Pi into products which run their proprietary software, and that's fantastic. Right, and that's kind of been the I guess the structure of the business has been to say, when we make investments in software, those investments are about making the chip run well. They tend to be low-level investments. They tend to be down towards the bottom of the stack or at very horizontal pieces of middleware, which are used by almost all users of our device. That means every dollar we spend on software tends to benefit everybody, or the vast majority of people who are using Raspberry Pi. Where you have more vertical spaces, we've tended to allow third parties, and third parties have been very successful in making those investments and also in reaping the benefits of those investments.
Mm-hmm, mm-hmm, mm-hmm. When you started it off and you launched Raspberry Pi, I pretty much remember that moment, that particular day when I could actually buy one in Germany because friends actually gave me like a voucher for one. Mm. And it was only available at electronic stores you never heard of before. And I think it was like a tremendous success back then. Like the launch, I can't imagine that like you were like calm and sitting there and you just, I think there must have been this moment when you said, this thing is exploding.
Well, interestingly, we launched it in Germany. So we launched it at Embedded World at the end of, so this is how we came to launch our product on the 29th of February. 2012. So it's an idiosyncratic choice in that it means that we've only actually had 2 birthdays in 2016 and 2020 so far. But and that date was driven by the fact that we wanted to show it at Embedded World in Nuremberg. But I was back in the UK for the launch, and there was certainly that feeling during the day. We sold about 100,000 Raspberry Pis, or took orders for about 100,000 Raspberry Pis on the first day. And there was certainly this really kind of slightly panicky feeling that we'd unleashed something beyond. We already had a slightly panicky feeling, right? This is an organization, it's a not-for-profit. It isn't able to go and raise risk capital in the market. It has no employees. It only has volunteers. And there was already a sense that it had grown, the level of interest in the concept of Raspberry Pi had grown beyond what this organization was easily capable of coping with. We became a licensing organization. The thing that really propelled the early growth of Raspberry Pi is, rather than trying to make them ourselves, we licensed the design to third parties who made them. And which is, of course, a trick we took out, an idea that we took from ARM's playbook, I guess, is the sort of other classic Cambridge company that has a very licensing-based approach to how it brings its IP to market. But there was that sense on the day, both our licensing partners' websites crashed. And there was just a sense that even though we'd resigned ourselves, got comfortable with the idea that this was going to be big. That it was maybe still an order of magnitude bigger. than kind of our wildest dreams.
And I mean, you did that through licensing partners, producing the hardware and so on, but like really having it ready for that launch, like how did you prepare for that? I mean, I think hardware is really tough, right? And how did you manage to do that successfully?
What were the biggest challenges? I guess there was a challenge associated with cost engineering the design down to the claimed price. So when we told people in May of 2011 that we were going to do Raspberry Pi, it was going to cost $25. We had a back of an envelope calculation, I think, that suggested that that was feasible. We did not have a finished product. We did not have a fully worked up bill of materials. And the back of an envelope calculation was very much based on the large pieces of silicon in the platform. So the processor, the memory, and the I/O controller. And those are things that cost multiple dollars each, and you add them up and they come to a lot less than $25. So you think, well, this is nailed on, we can definitely do this at $25, but there's a couple of things in your way. One of them is all of the other things on the device. There are a lot of things that cost 10 cents, and it's not the things that cost $1 that kill you. It's the things that cost 10 cents, because there are more than 10 times as many things that cost 10 cents than there are things that cost $1. So it's all of those components, SD card connectors, LDO power supplies, passives, things like little can capacitors, things like that. They actually cost quite a lot each. And then, of course, finding somebody who could make it for us, who we had access to, who could make it for us for a non-insane unit cost. And we actually ended up going to China. We actually ended up building in China. Our first couple of million units were built in Shenzhen. And then what we've done over time then is to reshore that manufacturing to the UK. But it was a big effort, and Pete Lomas, my co-founder, and Pete did the hardware design, and I sort of made the business model work. And it was a wild, probably between May and December. So we had our first, our first prototypes of the final device arrived a couple of days before Christmas. And then we launched 2 months later. So it was a wild 8 months to get to that prototype point, and then a very wild 2 months to finish off the business model, locate the manufacturer, launch production, start taking orders.
Crazy. And like there was no big bug in the first hardware that you discovered later on where you thought, this is bad.
There were always issues, right? There are always things you change. Have we ever had a product that we haven't changed after we've launched it? A bit. The first one, we had some challenges with how we approached protecting the USB ports from delivering too much current. So what we ended up having are devices called polyfuses, which are self-resetting semiconductor fuses that sit in between the 5 volts coming into the board and the 5 volts going out to the USB. And they just turn out to have awful resistance. So if you draw much current out of those, through those resistors, the USB voltage drops. And that was a very early change in the platform. So there were a few things like that. There were a few little buglets, nothing, but never anything that really impacted the experience of the vast majority of people. I've seen, what people tended to do was solder a wire across, bridge a wire, if they really cared, bridge a wire over those polyfuses. So the polyfuses came out of the design very quickly. Nothing horrible though. That's the flip side. I mentioned that, modern hardware needs a lot of software. The flip side of that is modern hardware is very remediable in software if it goes wrong. So there's so much software-driven content in the device that very often, if you find you have a hardware bug, very often bugs will turn out to be software bugs, not hardware bugs. And even if you have a hardware bug, often you'll find that you can write software to work around it.
So you were more focusing on the software or the general business back then, or
me, general business, bit of software.
Okay. And
so I'm a software and silicon engineer. So I'm not a electronic product engineer.
Okay, but you understand both worlds, I guess. Then,
there are 3 worlds. I think there's a world which is software. There's a world which is designing chips, and then there's a world which is putting the chips on a PCB and making an electronic product. And they're three very different worlds. And I kind of understand two of them. I've done two of them professionally. Electronic product design, I am an enthusiastic spectator of the work of my betters, I think is probably the best characterization.
Okay, still, as like one of the founders of the Raspberry Pi Foundation, you must be a good one to like shout out, let's say, 3 top learnings for techies who want to get into hardware and want to build a hardware company. Where you say, if you do this, then things will go wrong, or if you do,
I can do that. I think the thing that's very, very difficult is to say if you do these things will go right. Is a huge difference between that. I mean, I can certain behaviors will guarantee you failure. I'm not sure there are behaviors that guarantee you success. What have we learned about making hardware? Persistence, I guess, is one of them. That making hardware is hard, and you have to persist. You have to survive discouragement. That's an important one. Because we incorporated the foundation in 2008, and it took us until 2011 to have anything worth talking about. And then after that, it took us another year to launch a product. So it took 4 years to get anything done. And then Raspberry Pi obviously has then been around for a decade since and has posted, 40x performance increase. Basically, modern Raspberry Pi is about 40 times the performance of that first product. Huge amounts. You have to persist you have to persist just to get started, and then having got started, particularly if you've accidentally created a category-defining product like the Raspberry Pi, you have to keep going in order to keep ahead of the competition. So kind of persistence is very important. We discovered that the idea that the Far East is the right place to build electronics is largely a myth. I'm sure there was a time when building electronics in the Far East was unquestionably cheaper than building in Europe or North America. I think that era was largely over by the time Raspberry Pi came onto the scene. It wasn't trivial to reshore production to the UK, but it wasn't that hard either. And remember, here we're talking about a very cost-sensitive platform. Now, what it isn't, of course, is a platform that has a lot of assembly effort involved. You don't have half an hour of screwing tiny screws in to make a Raspberry Pi. It largely comes out of the oven, gets tested and put in a box and sold. So, you might still be able to make some sort of case for building iPhones or something in the Far East. But so that was really encouraging for me. We actually build in South Wales, which is where my family's from. It's an area that I guess has had some level of, deindustrialization during my life. And so it's been personally very satisfying for me to be able to bring some really high quality manufacturing jobs to my home bit of the world. What else did we learn? I think we learned the vast majority of people the vast majority of customers are very supportive of people who are trying to do interesting things, right? There will always be a tiny number of loud people who are unhappy regardless of what you do. But the huge majority of people, 99.9% of people, understand that what you're trying to do is hard. They're forgiving. If you do your best and you make something which is almost perfect, they are very forgiving about the almost, and they give you time to get rid of the almost. And that's been useful to us on a number of occasions. My favorite one of these was Raspberry Pi 2. If you took a picture of it using a flash gun, using a camera with a flash on, it would crash because it had a photosensitive component on it. Of course, nobody tests for that. And after it had been in the market for 4 or 5 days, somebody put 2 and 2 together because he really loved his Raspberry Pi, but every time he took a picture of it, it would stop working. And he put 2 and 2 together and said, "Does this thing crash when you take pictures? Is it photosensitive?" And so you have some of those things. Some of those things happen. But it makes hardware a wonderful place to do because people, as you say, people have a perception that it's hard. It is hard in a lot of ways, but it's also a really rewarding place to play, partly because you're one of the few people doing it.
So it's a bit like agile software development, just that your sprint length is at, 3 years?
3 years. 3 years. Just sprint Raspberry Pi 1, sprint Raspberry Pi 2, sprint Raspberry Pi 3. Oh man, a decade's gone, And
do you guys then, sit the whole day and like solder devices and
I sit the whole day and look at spreadsheets. I'm a chief executive. It's my job, right? I had a friend once who, in a previous role when I was more of a semiconductor guy, he said the problem with getting promoted, I was complaining that I didn't get to use the C compiler very much anymore. I tended to be doing PowerPoint and Excel. And he said, just you wait. He said, you'll get promoted 2 more times. And every time you get promoted, you get to a level where you're not allowed to do PowerPoint and Excel anymore. You're only allowed to send email to other people to ask them to do PowerPoint and Excel for you. And he was very right. Actually, it was very sage words. Largely what I do is email. I grind email every day. I come in and I grind my inbox. But there are people in the office who solder things every day. The interesting thing, of course, about chip work is how, I said there are 3 worlds, is how little soldering there is involved in the semiconductor world. That largely that is a software world. You sit there and you type what's effectively software into a synthesizable Verilog into a computer, and then one day you spend $1 million on one day to have a mask set made, and you wait 3 months, and then you get some chips back, and they either work or they don't. So it's a wonderful semiconductors is a wonderful sport for gamblers, right? Because the stakes are pretty high. The amounts of money involved are pretty high. the consequence of doing it wrong is pretty severe. Yeah.
So it's not hard. You just need that million.
It's not hard. You need $1 million and the right 10 people. You need... Semiconductors is interesting, right? Because it's interesting in lots of ways, but it's either impossible or tractable, or really quite tractable. And the thing that determines whether it's impossible or tractable is whether you have a person. There are probably 10 disciplines, say, in making 10 really distinguishable disciplines in making chips. And if you have one person who is extremely good at each of those 10 disciplines, and you have the money, you can make chips. And it is really pretty likely that when your chip comes back after you spend $1 million and waited 3 months, it's really pretty likely it'll come back and it'll work really well. If you don't have the 10 people, or you only have 8 of the 10 people, you have some of the disciplines aren't covered, it's basically impossible.
And where did you find A, the 10 people, and B, the $1 million?
The 10 people. So this is interesting. So this kind of comes on to the later evolution of Raspberry Pi. So you sort of see Raspberry Pi originally as having taken other people's silicon and put it down on boards and made electronic. So it's that not doing silicon, right? Building electronic products, not building silicon products. What changed last year as Raspberry Pi shipped its first product that had Raspberry Pi design silicon in. So where do you find the people? Well, a lot of the people involved in Raspberry Pi have been kicking around in the silicon industry for a long time. You get to meet people and you know who's good, and you make sure they can work for Raspberry Pi, right? Where do you get the $1 million from? You get the $1 million from selling Raspberry Pis. So you get the $1 million from the other business. So you get the $1 million from the board level products, and you move that money across into the semiconductor business.
So one thing I have a hard time to believe is that actually you mostly do spreadsheets and grind emails. In our pre-discussion, like you sat in a room where I felt like this is really nerdy. You had like boxes everywhere, and then I don't know, some measurement devices behind you, and it looked as
that was somebody else's desk.
Come on,
the trick there is that was somebody else's desk. No, that was James Adams's desk. James is one of the earliest employees at Raspberry Pi. He designed every Raspberry Pi apart from 3B Plus, I think. So he designed, Raspberry Pi 1, which was designed by Pete Lomas, and Raspberry Pi 3B Plus, which was designed by Roger Thornton. All of the mainline Raspberry Pis were all designed by one guy, James Adams. He's our COO. But I think COO is a greatly misleading job title for him, just as, I guess, if you think Elon Musk has CEO as his job title at a number of his companies, but I'm not sure that it really, say at SpaceX, I'm not sure it really fully encompasses the variety of activities that he engages in. I think James is probably our version of that with this COO job title, but he does not spend a huge amount of time on operations. He spends an awful lot of time on hardcore engineering. That's the desk you were looking at. My desk is messy, but in a different way. My desk is just messy, and it's covered in contracts, mostly that deep, I suppose. Printouts of things, but mostly printouts of legal documents.
Okay.
But I'm a computer programmer. I have written computer programs in the last month, but generally only for fun. One of the challenges when you're in my role, when you're a technical person, is the temptation is to get involved in to get deeply involved in technical stuff. I mean, I can be involved in technical things at an architectural level or at a review level. But if I get deeply involved in technical stuff on an operational level, actually doing the technical work, all I'll do is get in the way, right? Because I don't have enough time to, technical work tends to have a flow nature to it, right? It's a flow state thing, right? You need large blocks of uninterrupted time. I do not have large blocks of uninterrupted time. I live in a world of continual partial attention. And so if I try and do deep technical stuff, I'm going to suck at it and I'm going to get in the way of the professionals. And so my job is to soak up, significant fraction of my job is to soak up the continuous partial attention world to provide large blocks of continuous time to the technical people and not to get in their way.
That sounds meaningful, yeah.
It's great. I mean, it's incredibly meaningful. I mean, it's one of those things where you talk about, transition to, one of the challenges you see when we see people. I've seen people in my career transition from frontline engineering roles to management roles or leadership roles. And really, mine's a leadership role here, right? Is learning to get personal satisfaction and reward from the work that you enable others to do. It's a very difficult transition, actually, for very operational people, and not everybody successfully makes that transition. But it's something I've learned to find very rewarding, particularly in the context of the team we have here, who are very, very bright.
Was there that like one moment when you said, okay, this is the point where I have to jump off and I can't program anymore and I don't have those large blocks of uninterrupted time?
Yeah, probably 4 or 5 years ago. I remember the last major piece of software that I wrote in the Raspberry Pi platform, and that's half a decade ago now. Very intricate. The thing I'm good at is building fairly small, very intricate pieces of high-performance software. And there was a particular thing needed building, and I built it, and that's the last big piece of detail work that I've done. I mean, I've done lots of architectural work. I still do architectural work today, but not detailed implementation.
One anecdote from my recent vacation. So I went to Tyrol, as you know, and I went there with my girlfriend and with her brother as well, and his kids and so on. And he's working for BMW as an engineer, like leading engineer. And I was always joking at him, like, what are you doing at with your phone? Are you ordering radios at local Aldi to overcome the shortage you have in your market? And it's obviously a problem for them. And I recently actually bought a Raspberry Pi at Amazon, and I bought it for I think $130 or something, or euros. Like, how do you work against that? Like, and do you have a problem there? And how do you act against it? Do you buy radios at Aldi or anything? Or?
Yeah, that's it. Yeah, we buy radios at Aldi and we strip them for parts to build Raspberry Pis. That's always been. Honestly, that's been the business model since 2012. Aldi is very, very cost-effective place to buy semiconductors. It is a challenging time now. It's been a challenging time probably for the last 15 months, I suppose. We've all seen the pictures of Audi, car parks full of Audis that have no engine management computer in them. This world where everybody. I was doing home renovation last year. You can't buy cement. Cement is rationed. You can't buy more than 5 bags of cement at a time, right? Everything is in shortage. Semiconductor is incredibly in shortage. I think we've come to realize how little resilience there was built into our entire economy to deal with this we had this negative going and a positive going demand shock associated with the pandemic, and a negative going supply shock for a while. So it's challenging. We sold 7 million Raspberry Pis in 2020. We sold 7 million Raspberry Pis in 2021. but we entered 2021 with a 500,000 unit customer backlog. We left 2021 with a multi-million unit customer backlog, right? You know, the number of open orders on our order books. So it's a measure of it's a nice thing, right? It's a measure that people want our product. But the annoying thing is because of the supply chain challenges, we've not been able to scale up our production to meet those demands. What does that turn into? It turns into $100, $130 Raspberry Pis on Amazon, right? It turns into, while we regulate our pricing, it turns into a secondary market. It enables a secondary market around our product, which is not ideal, right? You know, we don't build our products and sell them at lean margins to enable some guy on Amazon to make, $60 of free money. So it isn't economically. That's not like all scalping, like reselling concert tickets, right? Or sports event tickets. It's not an economically productive activity, and it's sad to see it happen. What's been going on? What have we been doing to try and alleviate the situation? Obviously, building lots of Raspberry Pis. You know, we do have great relationships with our suppliers, and by and large, we have been able to maintain, not grow, but maintain our supply of silicon goods, of silicon products through this period. It does help, of course. We build our own silicon products now, so some of our products don't rely on third parties for silicon. You know, you got to bet Audi wish that they made the silicon that goes into their engine management computers, because then they wouldn't have the problems that they have. So that's been very helpful to us. So we've been able to maintain our supply of silicon, but not grow it. We've tended to, I think, to concentrate that supply a little bit on our industrial customers, slightly at the expense of our consumer customers. Why? Because our industrial customers have businesses to run. They have people to feed. They have people to pay. Those people have mortgages to pay, right? Where someone's livelihood is dependent on access to our products, we have a moral imperative to make sure that we prioritize those people to receive products. On the consumer side, what we've tended to do is work with our reseller partners to institute measures which reduce the risk of the behavior that you saw, right? So a lot of our resellers now, for consumer customers, will limit people to one unit. We've actually seen some people institute two-factor authentication. So Adafruit in New York, they're one of our resellers. They actually have now two-factor authentication. So you have to authenticate yourself as an individual using your phone in order to be able to buy Raspberry Pi products. And that's a further layer of defense against this kind of bot scalping kind of behavior.
Okay. And when the war happened now, was there a moment where you said, okay, now it's really over, or it continues like this? And is that true, or is it
what the supply chain crisis?
Yeah, I mean, it doesn't help, right?
It certainly doesn't help. It's not the most negative outcome of the war. Obviously, it's a fairly minor side effect. But the fact that you can't fly a plane on a Great Circle route from Taiwan to the United Kingdom anymore is not helpful. Because one thing you find is when you are in this, when you're in these kind of shortage situations, everything is just in time. You know, chips come out of the factory and you get them on a FedEx. You FedEx them. Where normally, you probably for chips, they're low enough volume, high enough value, you'll tend to air freight them. But everything just goes priority all the time. Having to fly via Doha, having to fly planes via the Middle East now to get from the Far East, to get from China or Taiwan to the UK adds a couple of days to an already kind of stretched supply environment. So that's difficult. I think the COVID lockdowns, the new wave of lockdowns in China, which are going to just, that's going to be a feature. That's going to be a feature of the world for as long as China tries to do this dynamic zero COVID thing. That's very disruptive, actually. So lots of stuff going on in the world at the moment. It's a very strange time, and a tough time to be trying to build electronic products.
Yeah, I can imagine. It really is crazy, right? If you look at it from like yesterday's perspective, essentially. It fits crazy. Yeah.
And one of the really interesting, article recently talked about the assumption we've always had that older process nodes will always get cheaper. That what happens is you have a new semiconductor process nodes, new generations of semiconductor technology come along, and the big volume, say smartphone chips, they go down. They're always on the fanciest process node, pretty much, or one of the 2 or 3 fanciest process nodes. And as they travel down through the process nodes, they leave behind them a trail of effectively completed factories that are no longer useful. And then other people like us come along, and we make chips like our RP2040 microcontroller so that's built on a 40 nanometer node, which was state of the art a decade ago. And there's a huge amount of fully amortized, paid for factory capacity on 40. And the assumption's always been that all of that other demand will fit into that capacity that was left behind. And of course, one of the big things that's happened is, at least temporarily, it doesn't. Some of that is COVID-related supply, COVID-related demand shock. Some of it is natural increases in the amount of compute intensity in our environment. So the attempt to deploy lots of IoT platforms, for example, does create demand for legacy process node chips. And the really fascinating question I don't think anyone has any answer for is, have we entered a new era in which semiconductor fabs are going to have to go back and spend more money on adding capacity on old process nodes, on legacy process nodes like 40. And that'll be a thing which will have potentially a very profound impact on the cost structure, on the business model of electronic hardware.
Shortly coming to my last questions, and maybe like more fun things than, what was the wildest thing that you've ever seen being done with a Raspberry Pi?
It's when we flew them to the International Space Station. It's that's us. I mean, I shouldn't talk about things we do as being the wildest things, but we put a pair on the space station in 2015, and we've just sent another pair up now to replace them. The idea that we're flying our hardware in space, that we have a space program, is just nuts to me. So that still really stands out. Other things I've enjoyed, the sort of very broad range of environments, physical environments in the UK, on Earth rather, that Raspberry Pis have ended up in Antarctica, watching penguins, and the tops of mountains and the bottoms of oceans and things. So seeing this, I guess, commercial off-the-shelf kind of COTS hardware taken into these environments, which are often the domain of very specialist computing platforms, has been exciting. I've enjoyed obviously watching kids use Raspberry Pi. A little thing, but I said I'm a software engineer, right? So my idea of what people would do with Raspberry Pi was to write computer programs, write computer games, because that's what I used to do with my BBC Micro. And the interesting thing that's happened, of course, is that young people are much more inclined to build robots. So we're trying to get more young people to come to Cambridge. We've gone from 250 applicants to computer science a year in 2008 to over 1,500 last year. So that's an enormous growth. And when you ask those people, how did you get involved in computers? What they all say is Raspberry Pi and robots. And so that sort of triumph of that second world, the electronics world, neither the software world nor the silicon world, that triumph of the electronics world in education has been that's wild to me, right? You get these little kids, tiny little kids, making robots with our products, and that's wonderful to see.
And how can you prevent? I guess you can't prevent it as you build the platform, but how could you prevent like big kids using it for the wrong things? I mean, like rockets or whatever.
Yeah, right. It's always a worry, particularly in tough times in the world. We make knives, right?
Yeah.
We make general purpose tools. And the moral challenge with general purpose tools is that they are They are value. They don't have a moral value associated with them. They are just tools, and you can use them for good things, and you can use them for bad things. And you can do your best to make sure they're not used for bad things. I mean, right now, of course, we've recently had to pay a little bit more attention to export restrictions on our products over the last month or so to prevent them from potentially being used for bad things. But in the end, you have to resign yourself to the fact that bad things are going to happen, and you hope the good things outweigh the bad things.
Mm-hmm. I think, like, from my perspective, you always tried to avoid your computer being spread in the secondary markets and so on, and like purely being sold through reliable partners and so on. So I think that's already like,
and that does give you if they're mostly going out through people with whom you have a contractual relationship and a personal relationship. The wonderful thing about our network of approved resellers is they are friends. Many of them, they are people we know very well, and they are people who share our moral values. While of course, we have we place contractual restrictions on our resellers' right to say resell to countries that are on various lists. At the moment, we actually know that even if we didn't impose contractual limits on them, they would understand and do the right thing anyway.
Okay, so I have two more positive questions. So, what is? I mean, you're a nerd in your by heart, I guess. Is there like a latest, most recent nerd discovery that you made, all your friends with, like a tool or something you like playing with all the time and tell all your friends about?
Ooh, well, that's one that would have required a bit of preparation, I think.
I'm sorry.
What do I enjoy at the moment? I'm just mostly stuff with kids. They know what they're like. They eat your life. I have a 2-year-old who loves. Nearly 2-year-old who loves dinosaurs. So what have I discovered more? Okay, there's a thing. Okay, this is not a tool. This is a lifestyle thing, right? Spotify. Actually, what tool am I using more and more in my life in a variety of different ways? I'm using Spotify a lot. We have a family Spotify subscription, and I use it to entertain my children in the car, and I use it to get my children to sleep, and I use it as part of a increasingly desperate attempt to not become a dad. You know what I mean? A dad. To stay vaguely connected to modern popular culture. And so that's the thing. But there's something about having all of, you see this with video streaming services as well. There's something about having all of the output of mankind's efforts in some area available to you. That's deeply, it's both wonderful, and sort of challenging in terms of knowing what to do. And this is knowing what to do with that capability. And it's very easy to use the capability to just tunnel further. Same is true of lots of platforms. Same is true of social media, I suppose, as well. There's a tendency to tunnel down into your comfort zone, to huddle down into your comfort zone. You can use these technologies to huddle into your comfort zone, and you can use these technologies to try to broaden your mind a little bit. And certainly, social media as well. Try that very much. I follow so many people on social media who I find really annoying, whose say political views are so opposite to mine, and my finger hovers over the unfollow button, and I force myself to not to click. So there's that whole family of tools that gives you the opportunity to broaden your horizons or narrow your horizons, and the eternal wrestling match with comfort, with taking the comfortable option in those spaces. I listen to a lot more classical music than I used to, partly because of my 2-year-old son, who's comforted by classical music. It sounds like a terrible parent brag thing, isn't it? Right? Maybe my 2-year-old likes lots of classical music, but he does really like lots of. He finds it very comforting, and so I am listening to a lot more opera. When I say a lot more opera, I'm listening to some opera now, and that's the thing. There you are, and I talk endlessly and boringly about it, but yeah. There you are.
But that's
bet
great.
You didn't think that. Bet you didn't think it was going to go that way. Bet you thought it was going to be a really cool new front end for Git.
Yes,
or something.
I was hoping for that. But still, Spotify also comes with complexity if you are a young dad. Like for me, it's no longer working for a few years. Like mostly not working anymore because I get all those. I tend to listen to all those recommendations, and now it's like full with kids.
Oh, show tunes! So many show tunes. I've listened to the Encanto soundtrack so often that if I allow it to run it, I mean that's quite nice actually, because one of the things that drives you into your comfort zone in social media and that drives you into your filter bubble in social media and in things like Spotify and and streaming services is the recommendation engine, is its attempt to profile you and give you more of what you like. And of course, there's no more powerful way to do this than to use the same Spotify account to listen to the Encanto soundtrack 300 times or the Disney Descendants soundtrack 300 times, and then attempt to get the thing to serve you things that aren't show tunes and Pixar music. Yeah.
So you also might know Peppa Pig and so on. So
we have successfully insulated our daughter, who's now nearly 5, from the pig, as we call her. One of the problems with the pig isn't the pig's father an engineer who's also useless. I think the representation. I don't know anything about the pig, but my understanding is that the pig's father is a useless fat engineer, and so I'm very sensitive about the pig. She has a football. We went to the park once, and she found a discarded Peppa Pig football, and that is her only exposure to the pig. Somebody did expose our 2-year-old to Baby Shark, though, so I'm still fuming a little bit that Baby Shark is now a thing in our lives.
So, coming to my last question, which is not as funny as this one. Your co-founder Pete actually told me about your best kept secret in the Raspberry Pi Foundation. It's actually like an Easter egg that you built into the board. It actually, like if you pin together, if you connect pin 2 and pin 36 of your GPIO board, it actually magically enables the time machine mode in your Raspberry Pi, and it creates then like a dev/time machine, and then you can pipe in a year. And we pipe in the year 1995, and now we travel into the year 1995. And I think you worked as software engineer at IBM back then. And we can now observe yourself for a little while. And I ask you now, what would you whisper into young Eben's ears?
Well, I had somebody to do this job for me. Even then, I had a good friend of mine, Graham Sanderson, who I met in 1995 at IBM, who did most of the whispering into my ear about what I should pay attention to in the way of becoming a proper engineer, and he's still cleverer than me, which is infuriating. I think, setting aside business things, it took me a long time to learn how to work properly. I think I struggled as an undergraduate with not knowing how to work hard at things. To work hard at things that I'm not naturally good at, and I think I then figured it out later on. So I figured it out when I did some postgraduate work, and so I think if I could go back and give something to me back then, it would have been some of that perspective on how to work. And I think it's a funny. I came to Cambridge. I went to school went to a state school in the UK, and I went to Cambridge. School is very easy, and Cambridge is very hard. And I and many other people struggle with this transition, and I certainly struggled with that transition. Yeah, I think that's probably what I would have done, actually, because I do regret my undergraduate time not having squeezed more value out of those 3 years, from when I was 18 to when I was 21. And that would probably be the thing. There you are. It's a sad thing, right? And, all went all right in the end. I got the PhD and the MBA, and it was fine. But I still don't understand thermodynamics properly, statistical thermodynamics. And that makes me sad.
So go to school again then.
No, well, I tell you what, why don't you go tell my wife that? So I went to Cambridge 4 times. I went as an undergraduate, did the postgraduate diploma, did the PhD, did the MBA. I have had it made clear to me that I am not going back to school.
Okay, then that's fine. Thanks a lot for your time, Eben. It was a lot of fun talking to you. And hope to see you again soon. Hope to hear more from Raspberry Pi in the future. I guess we all will. Like, when is your next device coming out?
Well, there you see. I could tell you, but I'd have to kill you. It will happen. I do think that the middle of a global semiconductor shortage is probably not that time. But we're always what's been great for us is Raspberry Pi 4 has enormous legs. It's nearly a 3-year-old product now. We've managed to squeeze a lot of performance out of it already. There's a lot more squeezing to do. But one day.
One day. Okay. Looking forward to that one day. Thanks a lot, Eben.
Thank you very much indeed.
Enjoy your day. Bye-bye.
Cheers. Bye.
Thank you for listening to the AlphaList podcast. If you like this episode, share it with friends. I'm sure they love it too. Make sure to subscribe so you can hear deep insights into technical leadership and technology trends as they become available. Also, please tell us if there is a topic you would like to hear more about or a technical leader whose brain you would like us to pick. AlphaList is all about helping CTOs getting access to the insights they need to make the best decisions for their company. Please send us suggestions to cto@alphalist.com. Send me a message on LinkedIn or Twitter. After all, the more knowledge we bring to CTOs, the more growth we see in tech. Or, as we say on AlphaList, accumulated knowledge to accelerate growth. See you in the next episode.